which is partially going to look familiar. Because 4.4 is factoring. Now, I am going to mix together the notes a little bit for day 1 and day 2. Today was day 1, obviously, because one of the things I want to do is I want to get those different methods of factoring pointed out to you all on one page. Put the phone away before it's mine, please. Factoring we've done before. What is the first thing you should always do when you're trying to factor? Greatest common factor, GCF. In other words, quote unquote, divide the biggest thing out of everything. Emphasis on everything. It divides out of every single term. Now, just some quick reminders when it comes to greatest common factoring. First off, just a reminder to always start with this. Regardless of what the polynomial looks like, you should always try greatest common factor factoring first. It's going to save you the headache with some big numbers. Another common thing that I've been seeing people do, or forgetting to do, remember to put the GCF, that greatest common factor, in front of the parentheses. One of the things I've seen people doing, say they have 2x squared plus 4x plus 6. They divide everything by 2. They leave me with x squared plus 2x plus 3. And they just leave it like that. You changed the problem. You can't do that. So don't forget to put it out front. Another thing, you have to check for factoring still. If you're going to factor something completely, a greatest common factor is a starting point. Now, for some problems, it is the only thing you can do, but not for all of them. What's another form of factoring that we did? AC method factoring. Works when we have quadratics in the form of ax squared plus bx plus c. When you were doing AC method factoring, there's steps that you go through. A times C off to the side. This is one of the most common things that I see people miss in AC method. It's not the most common. The most common we'll talk about here in a second. But oftentimes people just look at C instead of pulling AC off to the side because they're mixing it up with another method. After you do that, you got those things off to the side, you find two numbers that multiply to AC. But add to B. The third step of the AC method factoring is the thing that people tend to forget most. It's called the rewrite step, if you ask me. you rewrite the bx term as the sum of the two numbers you found with x on them, or whatever variable it is in the problem. Just use an x as reference. When you do this, you will have 4 terms in your polynomial now. Do not combine them. You are undoing your work. Now, I haven't seen a whole lot of that going on. That is one common mistake that I see happening. You guys, for the most part, have not been doing that. We like it in 4 terms because then we can break it into 2 halves. Where we can factor out the GCF from each half. And the final thing we do is we write in the factored form. Factored form should have the double parentheses. The first set of parentheses, I put the plus sign in there because it's something that tends to get missed on that one. The 2 things that go there are the GCFs from each half. They do get added. The second set of parentheses matches the existing parentheses. One thing that I have noticed has been not as common of an error, but it's been a hiccup, is getting to that final factored form. So just reminding us of those steps. What's another method of factoring we've been doing? The shortcut to the AC method. Now, do you have to know the shortcut? No. You can always do the full AC method, but you cannot mix up the shortcut and the full AC method. When can we do the shortcut? When that x squared has got a 1 in front of it. When it's x squared plus bx plus c. In other words, the a is equal to 1. Not negative 1. 1. In this method, you jump directly to finding the 2 numbers. They will multiply to c. And to add to b. Here's where people get AC and shortcut mixed up, is that in the full AC method, once you have those 2 numbers, you have to do a rewrite step. In the shortcut, you do not. In the shortcut, you can go directly to writing in the full factored form. Where it'll be x plus one of the numbers and x plus the other number. If they're negatives, plus a negative is minus. Now, those were the first 3 methods of factoring that we talked about. But within those, we actually do, why did I write 3? We do somewhat actually have a 4th method. It's one we haven't really talked about. I've mentioned it, but you've been doing it. It's called factoring by grouping. Factoring by grouping is for polynomials with 4 or more terms. It's for the bigger polynomials. Now, you might be questioning right now, like, what the heck do you mean, Benson? We haven't been factoring polynomials with 4 or more terms. What do you mean we've been doing this already? Might get a little more clear when I talk about the steps of factoring by grouping. So, when you are factoring by grouping, what you are going to do is you are going to break the polynomial into 2 halves. And you're going to factor out the GCF from each. Now, assuming that once you've done this, the parentheses match, because they technically should. If they don't match, try regrouping and try again. Just reorder the polynomial. We'll talk about that a little bit. It doesn't happen very often that you have to do that. But assuming they match, you can write in the factored form. Which will have 2 sets of parentheses. And in the first set of parentheses, where you've got these 2 slots getting separated by a plus sign, you should put the GCF from each half. And then the other parenthesis should be the thing that matches the existing parentheses. Do these steps sound somewhat familiar, maybe with the exception of the regrouping? Break into halves, factor out the GCF, then pull the GCFs into one parentheses and the other parenthesis matches the existing. Where else have we seen that? In the middle of the AC method. AC method builds itself on factoring by grouping. The last couple steps of the AC method is factoring by grouping. The only thing that's slightly different is that in the middle of the AC method, you will never have to regroup. You'll never have to change the order of the polynomial. Now, there are 3 other forms of factoring that we are going to talk about tomorrow. I am going to add them to our list of ways that we can factor, which means I'm going to leave myself some empty space to do that on my notes. I still can't hear you. Yeah. I'm not going to write to be continued because I want to actually write it there. But, yes, essentially, to be continued. I'm going to start about halfway through my second page just to give myself enough room. I don't think it'll take quite that much room to talk about the other 3 forms of factoring we're going to talk about tomorrow, but I'd rather us have extra room than run out of room. If you are just going to group it by day 1 and day 2 because that's the way you'd prefer it, do as you wish. So, we're going to factor. Specifically, factor completely. going to start with 30x to the 8th minus 195x to the 5th. What should we always start with again? GCF, biggest thing that divides out of everything. What's the biggest number that divides out of 30 and 195? It's actually not 5. I chose this one on purpose because I saw something happen in chapter 2 where people weren't getting the greatest common factor. So I want to address that. Let's say you did think it was 5. It would not only be 5, look at variables too. It would be 5 what? 5x to the 5th power. Let's say that's what we did. Now, greatest common factor factoring is essentially dividing it out of each of the individual terms. 30 divided by 5 is 6. X to the 8th divided by x to the 5th would give me x to the 3rd. Okay, negative divided by positive is negative. 195 divided by 5. What was that? I think I misheard. Because I heard 30 and that's not right. I keep just hearing 30. 30 what? 9. Okay, got it. 39 and the x's are gone? That was not the greatest common factor. It was a common factor. It was not the greatest. Here's how I know. Look at what's left in those parentheses. Do they divide by something? What do they divide by? 3. Do it again. If you don't get the greatest common factor, look at the stuff inside and see if there's still a greatest common factor. If you're not positive that you got the biggest number, see if it still does more. We would get 5x to the 5th. Now we're multiplying by a 3 that we're factoring out. We'd be left with 2x cubed minus 13. Do the parentheses still divide by something? No, which means now we got the biggest thing out. The last thing we just have to do is simplify this stuff. The greatest common factor should have been 15x to the 5th power. Had you noticed the 15? It would have been fewer steps. Specifically, 1 step. You would have gone directly from here to here. Assuming, of course, you got the x to the 5th at the same time. So, if you are struggling to find the greatest common factor, my point is, find any common factor. Even if it's one that you're like, I know that there's gotta be bigger things, but I don't know what they are. So if you get big numbers like 224x plus 586, and you're like, they've gotta be big numbers, but all I can think of is 2. Start with 2. And then try again and see if there's another number. I don't know if more comes out of that one. That one actually might have just been 2. But my point is, if you can't see it, start with something and then keep going. Okay, now at this point we got to see if this factors further. Can we factor 2x cubed minus 13 further using a different method? Do we know a method for a 3rd power currently? No, not except for greatest common factor, or technically grouping will work with higher powers too, but it doesn't have 4 or more terms. We will learn a version for to the power of 3. That one technically still would not factor further. (3x squared minus 12). Start with your GCF. 3. Leaves me with x squared minus 4. Can I factor that further? Maybe at least we could check. It is quadratic. It appears to be missing a term. What term is it missing? X. If it helps you do it by putting that x term in there, go ahead and do it. Do you have to? No. Do you need to know there's a 0 in front of it? Yeah. Shortcut or full AC? I'd do the shortcut. Two things multiplied to -4, but add to 0. -2, +2. Go directly to the parentheses. X minus 2, x plus 2. Don't forget to put the GCF back out front. That's my fully factored form. I start with greatest common factor. It's the biggest thing that divides out of all 4 terms. 1. Does a GCF of 1 typically do anything for us? No. Is there another form of factoring we can use? 4 or more terms is factoring by grouping. Now, you might notice this is not in standard form. In factoring by grouping, it doesn't technically need to be in standard form. If you would prefer to have it in standard form, you can move it into standard form. It's called regrouping. Sometimes regrouping will make life easier. Is it going to be easier to see what factors out of 5x cubed and 8x or 5x cubed and 10x squared? Probably 10x squared. There are also times where you might have to regroup in order to get it to factor. So, if it helps you to flip it around, this is what regroup means, is flip those around and then do the 2 halves. You don't always have to do this. We'll talk about when you have to do it here in just in a second when it pops up to that point where we check. Okay, I break into my 2 halves. Out of the first half, what can I factor out? 5x to the power of 2. Don't forget the variables. That's one of the things that I've seen in the AC method that people have been missing, is they've been missing the variables as they're doing GCF in the middle of AC method. Okay, factor out 5x squared. What am I left with? Divide this by this, I'm left with an x. Divide this by this, I'm left with a 2. +2, so +2. Greatest common factor of -8x minus 16? -8, because I want my parentheses to match. Leaves me with an x plus 2. Here is where you might have to do a regroup. If, no matter what you do, positive or negative, you do not get those parentheses to match, which sometimes will happen in factoring by grouping, then go back to what you had and do the regroup. Flip-flop the 2 middle terms. And then try again. That's not my final factored form. My final factored form looks like what? 5x squared minus 8, and x plus 2. Now, one of the things that I left off of factoring by grouping, and I didn't mean to leave it off, is after you do factoring by grouping, there is one other thing you need to do with this. Check for further factoring. My bad. I just legitimately missed that. I didn't mean to. But there are times when after you've done factoring by grouping, you can continue to factor. Because when you're factoring by grouping, generally, unless it's in the middle of AC method, generally what's going to happen is you're going to get a quadratic or higher degreed polynomial left. For example, on this one, we got 5x squared minus 8. And sometimes it'll be something that continues to factor. If you see 5x squared minus 8, shortcut or full AC method? You'd have to do full AC. I would do 5 times negative 8 off to the side. I would get negative 40, and I'd look for two things that multiply to negative 40 but add to 0. It's got to add to 0. It's essentially got to be the square root of the number. Is the square root of 40 a nice number? No, which means this one's not going to go any further. But there will be times where it can. This is just not one of those times. It doesn't happen overly often, but it does happen. Okay, I got 2 more examples today, and then we're going to be done with examples for today. Four x squared minus 15x plus 9. First thing we look for is always what again? GCF. Biggest thing that divides out of 4x squared minus 15x plus 9. If you are struggling to come up with GCF, if you are wondering how the heck some people know it's 1 right away, and that's one that I've seen a couple people tripping up. They're like, I can see when it's things like 2, that makes sense, but how do you know when it's 1? Look at the smaller, generally I start with the smallest number and say, okay, what things divide out of 4? 2 or bigger would be 4. And then I look at the next smaller number. Does 9 divide by 2? Does 9 divide by 4? If those were the only things that divided out of 4 and they don't divide out of 9, that's why the GCF is 1. So, just something to keep an eye on. Okay, full AC method or shortcut? Full AC. Off to the side, what am I multiplying together? 4 times 9. 36. Looking for 2 numbers that multiply to 36 but add to negative 15. Is it going to be a positive and negative? Positive times negative would have to multiply to a negative. That's another common mistake I'm seeing, is people see this as negative and assume that it's 1 positive, 1 negative. If this is positive, it's either 2 positives or 2 negatives. To add to a negative, it's 2 negatives. Again, if you are struggling with this, just start doing the counting numbers. 1 times what? 2 times what? And use your calculator. If you don't know what 2 times what is 36, go to your calculator and do 36 divided by 2. 3 times 12, 4 times 9, and then eventually you get 6 times 6. That's all the options. I want them to all to be negative. Which pair is adding to negative 15? Negative 3, negative 12. Did I have to write all of them if I see which number it is? No. is my factored form, x minus 3, x minus 12. Again, that's the most common mistake I'm seeing. Once I find these two numbers in the AC method, what do I need to do? Rewrite it with the middle term being those two terms added together. 4x squared minus 3x minus 12x plus 9. The 4x squared stays, the 9 stays, the negative 15x becomes those two. This way I can break into 2 halves and factor by grouping. It's the biggest thing I could divide out of 4x squared minus 3x. X. Don't forget the variable, and sometimes it's only the variable. Leaves me with 4x minus 3. Negative 12x plus 9, 3. But if I factor out a regular 3, I'm going to get a negative 4x and a positive 9. So do negative 3 instead. It'll leave me with a positive 4x and a minus 3. What is the fully factored form? A 4x minus 3, that's from the matching parentheses, and an x minus 3, that's from the GCFs. Traditionally, I would have written x minus 3 first and 4x minus 3 second. It doesn't matter the order of them. I got one final example, and this one I'm going to challenge you to try out on your own. I won't say, oh no, like it's the end of the world. And just to clarify, yes, you all need to try it. I'm going to write down, go through it up here real quick so that I got it on the video, and then I'll be coming around, checking on people's progress and handing out today's worksheet. Do the problem first.